We are doing a dosing problem. An oral suspension, 0.75 grams, every 6 hours is ordered. The suspension is available with 250 milligrams per 5 milliliters. We're asked how many teaspoons should you instruct the child's mother to administer per dose. In order to solve this problem, we're going to start with the ordered amount and try to convert it over to teaspoons. We'll start with the dimensional analysis approach. In dimensional analysis, we'll start with what is ordered, in this case 0.75 grams. We'll place that over 1. In my next fraction, I need grams to be on the bottom of the fraction so that it cancels. When I look at what is available, it is given in milligrams, so although I need to use this information, I cannot use it right now. First, I need to convert the grams into milligrams. So I have memorized that 1 gram is the same as 1,000 milligrams. Now the label of grams cancels and I'm working with milligrams. I'll need to put milligrams on the bottom of my fraction. From the available medication, I know that there are 250 milligrams per 5 milliliters. This allows me to cancel milligrams. However, my problem asks me how many teaspoons, so I need to convert to teaspoons. I'll put milliliters in the denominator, and I have memorized that there are 5 milliliters per 1 teaspoon. This allows me to cancel the label of milliliters. Now my answer will be in teaspoons because that's my only uncanceled label, and I'm ready to do the math. So I'll take 0.75 times 1,000 times 5 divided by 250 divided by 5. And when I do all of that work, I come up with an answer of 3 teaspoons. A second approach to the problem is to use the nursing formula. In the nursing formula approach, we start with the desired amount or the doctor's order. So in this case, 0.75 grams. We put that over what we have on hand. The have on hand is from the dosage strength, in this case 250 milligrams. We multiply by the quantity that the medication is in this case 5 milliliters. Now, although we have placed the right numbers into the nursing formula, we are not able to solve the problem. In the nursing formula, the labels between the desired and the have must cancel. They do not. We can fix this using the mnemonic device of King Henry and our metric line. So we have memorized King Henry died by drinking chocolate milk full of microorganisms. The G in grams is represented by the B as the basic unit. To move to milligrams, I'll need to move along the metric line 3 jumps. So I move my decimal 1, 2, 3 jumps. That changes the desired amount to be an equivalent 750 milligrams. Now the labels of milligrams cancel from top to bottom. So that part is ready to do the math. However, I'm not supposed to give an answer in milliliters. I'm supposed to give an answer in teaspoons. So I need to convert the 5 milliliters into teaspoons. Thankfully, this is an easy conversion because I have memorized that 5 milliliters is exactly the same as 1 teaspoon. So I'll replace the 5 milliliters with an equivalent amount of 1 teaspoon. I'm going to rewrite all that I've done so that you can see it clearly. The order has been changed using the metric line to 750 milligrams. That is the desired amount. What we have on hand is 250 milligrams, and that is in a quantity of 1 teaspoon. Now our milligrams clearly cancel, which is essential in the nursing formula. We can do the math, we multiply, and our label on our answer is teaspoons, so we end up with exactly 3 teaspoons. Final approach to the problem is to use the proportion method. With a proportion, we want to create equal fractions. We'll always start the proportion method with what has been ordered, in this case 0.75 grams. And we'll place it over an X with the label that we'd like to change it into, in this case teaspoons. We'll put the dosage strength as our second fraction, as a first attempt at creating a proportion. The dosage strength is 250 milligrams per 5 milliliters. Now this is not actually a proportion, because a proportion is saying that two fractions are equal. And when I look at the labels across the top or across the bottom, the labels don't match, so it is impossible for these fractions to be equal. So I need to do some conversions within my proportion to make it work. On the top, I have grams and milligrams. I can change them to be matching labels by using the metric line. So I have memorized King Henry died by drinking chocolate milk full of microorganisms. The G for grams is represented by the B as a basic unit. And so from my metric line, I realize I need to move my decimal 1, 2, 3 places in order to change to milligrams. So this amount becomes 750 milligrams. This now gives me matching labels on the top of my fractions, so I am closer to having a true proportion. On the bottom of my fractions, I have teaspoons and milliliters. This is an easy conversion because I have memorized that 5 milliliters is equivalent to a teaspoon, so I can replace this with 1 teaspoon. I'm going to rewrite my proportion. It is truly a proportion now because the labels match, and so I do have equal fractions. So my first fraction is 750 milligrams over X teaspoons. And my second fraction is 250 milligrams over 1 teaspoon. To solve this, I cross multiply. So multiplying on my first diagonal, I have 750 times 1, which is 750. Multiplying on the second diagonal, I have X times 250, which we write as 250X. I solve by dividing both sides by 250. That allows me to cancel these 250s to get X equals, and I do the math here, and the answer is 3. Looking back at my proportion, the label on that 3 is teaspoons.